All right, so let's talk about how we build our own procedures or functions. Um, so I'm going to start in Logo here. But before you start writing a function, it's good to do a little bit of thinking about what you want it to do and how it's going to work. So let's say we're going to write a program to find the area of a rectangle. So one of the first things to do actually is just to write down what your function is going to do, and you write that in a comment. So any text that you write in microworlds that's not in the body of the function, and we'll talk about the body and the header and all that in a second, that is taken to be a comment. So if I just write the sentence, find the area of a rectangle, as long as it's not inside, in between these two and end, any of these two end pairs, it's just going to be ignored by microworlds. But you're writing that for your information, okay? So let's start by making a diagram. Let's say we want to have a function. We'll call it rectangle area. Okay. We want it to be a reporter because it's going to tell us what the area is. It's going to report that information. And we want to give it two inputs. We want to give it the width and the length of the rectangle. So let's draw that. Okay. So here's the basic idea of what we want. Okay. So what this is telling me here is that we're going to need two inputs. Okay. So what we need to do is give names to those inputs that we can use inside this tank here. So let me actually, I'm going to have to stretch out this tank a little bit to give me some room here. So I'm going to grab this, let's see, part of it, and smooch it down a little bit. That should be enough. And then draw some lines here. Let me see. Oh, too big. Okay, so because I'm going to want two inputs, and I want to have names for the inputs so that I can work with them while I'm inside my function. So I'll call one of my inputs width. Let me move this guy over to make sure I don't draw on my picture. Width. Oops. I'm clicking on here, this guy. Width. And I'm going to name one of them height. All right. So inside my function, I'm going to have a width and a height. Okay. And those are going to be my inputs. So when I input a number, that number is going to be assigned to the variable width. Okay. And that variable is just exists inside this box, inside this function. Okay. And I think I'll also create an area so I can have that for my output. I think that'll just look nice here. Okay, so let's say, let's call it this, and that's going to be my output. Okay, so there's some stuff going on here. And the stuff that, so we have two inputs, width and height. We output the area, and there's stuff going on in the middle that uses width and height to calculate the area. Okay, so what does that look like? Well, in Logo, and I'm showing you a lot of these examples in two different languages because I want you to start thinking about the design of programming languages. When you start thinking that way, it makes it easier to kind of understand where the designers of the language are coming from, and so you understand better how the language works. One of the tasks that the designer of a programming language has is to give programmers a way to define functions, right? If it's a language that supports the development of functions, which most of them do, some way or another. So in Logo, the way that they approached that task was they said, well, we're going to have a word to mark the beginning of the function definition, and we're going to have a word to mark the end of the function definition. Okay, so when the interpreter is the piece of software that translates your code into machine code, when it gets down to the word to, it says, this is the beginning of a function definition. And it reads through and does what it needs to do until it gets to end. And it says, okay, now I'm done. Okay? So there's this top line we refer to as the header, the function header, or the procedure header. And what it contains in Logo is it has the keyword to, then it has the name of the function or procedure, and then any inputs. It gives it gives names for any of the inputs that you might have. So I'm going to say colon width colon height. So now I know that whatever I give when I go to use this function, so right now I'm just defining the function. I'm adding the word rectangle area to the vocabulary for microworlds so that microworlds will know how to do this. But when I actually go to use rectangle area, what this immediately tells me is I need two inputs. Okay, I'm going to have two inputs. And then in the body of the procedure, I'm going to explain what I do with the inputs, basically. So I'm going to say output width times height. Okay, so which makes sense. That'll give me the area of the rectangle, right? But I did say I'm going to use area in here, didn't I? So I could say something like make. I think I need to. We're gonna talk about local and global variables shortly, but I'm gonna cheat and because I want to make sure that this just lives inside the function. So if I say local, okay. So I'm going to say, and I'll explain this a little bit better in another video, but I'm going to say local area right here. And then I'm going to say make area width times height and output area. Okay, so Yeah, I'm making this longer than it had to be just because I wanted to illustrate that, we have this output thing here, area. But so the idea is that we have some words, some variables that have meaning only inside this function. Okay. We have inputs. We have two inputs, and we have an output, which is the area of the function. So now we're not done. So what we need to do is make sure that it does what it's supposed to do, right? So let's think if we have two inputs like 2 and 3, let's say, for example. So here's our, now we want to, our function is a reporter, so we're going to show what it reports here. So rectangle area, let's say 2 and 3, it should output 6, right? So you want to predict what it should output and check and make sure it works. Yeah. And you might want to, do a few more. Oops, 3 and 5 should output 15, right? Okay, so that's the idea. Let's just real quick do the same thing in Code Sculptor. I want to save that, so let me pull up another copy. Code Sculptor. So let's do calculate the area of a rectangle. And I want to emphasize, so this comment in here, if I haven't said this already, whenever you write code, you're writing it for two audiences. One is the computer, or the software that translates your code into machine language, right? So that it's important that works. But you're also writing your code for every programmer who's ever going to have to read your code and try to use it for something. Okay? And your code does not work unless it works for both audiences. So this is why we use meaningful names for variables and function names. This is why we use comments. Anything that you can do to make your code more understandable, as well as working correctly, is critical for doing a good job. Okay, so again, the people who designed Python had the same problem about trying to figure out, okay, how do we make it clear, and you need to make it clear. Again, you need to make it clear to the software that's translating your code into machine language, and you need to make it clear to the programmer where a function begins and where it ends, right? So in Python, the way we start a function, instead of the keyword to, like we use in Logo, there's a keyword def, basically for definition, because you're defining a function, right? So you have that function definition, then you have the name of the function. Okay, now I'm going to write this a little bit differently. You saw in Logo, I used rectangle area, and again, the machine needs to have a way of saying, of knowing when we're done reading the procedure name. Now we have the complete procedure name, and now I have to check and see if there are any variables, right? Or if there are any input parameters and any inputs. So what we do is, in Logo and in Python, you'll see this too, is that we have our complete name has no spaces in it. Okay, so you would never do something like rectangle space area, because that makes it, because the software for reading the procedures, it makes it too much work, basically, for the interpreter or the compiler to figure out when we're finished reading the procedure name and when we're starting with inputs. Okay, so we just make our procedure names without any blanks in them. And the convention that I use in Logo, and this is really, like I think I said earlier, this is really from Java, is to I have a lowercase to begin my procedure name, but then if I have any other words that if I want to make it a multi-word name, I'll just start with a capital letter. But in Python, the convention is to use an underscore in between. And again, everything's lowercase. Okay. Now in Logo, the way that they decided, okay, we need to have a way of making clear what the inputs are. So what they do in Logo is they put a colon in front of the input name, and they separate the input names with a space. Okay. In Python, what we do is we put parentheses around all the input parameters. And what I do is when I make an opening parentheses, I make a closing one, and then I click my pointer and go inside. It just helps me keep track of, because sometimes you have parentheses inside parentheses. It's just easier that way. And then we can put our variable names inside. So see, we don't have colons in front. In fact, colons would be invalid as part of a variable name. But we use a colon. What we use a colon for is to mark the end of the header line. Okay. So now we've read through, our interpreter or compiler or whatever you're using has read through and seen the entire header for this function. So we know we're defining a function called rectangle area that has a width and a length. Okay. And just like, okay, so then let's define, we'll say area equals width times length. Okay. And let's return area. Okay. So now notice when I hit the return key, I automatically got this indentation here. Okay. Indenting is critical in Python. So in Logo, it absolutely doesn't matter. You can indent all this stuff inside if you want. You can tab over, but you don't have to, because we use this to and end in Logo. Okay, so the designers of Logo said, well, we'll mark the beginning with a to and the end with an end. In Python, what they decided to do, and there, you can argue whether this was a good design choice or not, but it is easier in some ways than some other languages, or clearer. What happens is they say, okay, we're going to mark this, use this colon to say, okay, everything below here belongs to this function, and then everything that's indented under this under here is part of this block, this piece of code. Okay, so now this defines our whole function here. So now we've defined our function. So let's press run, and nothing happens. Okay, so why is that? Well, just like in MicroWorlds over here, when you define a function, you put it in the procedure tab, all you're doing is adding it to the vocabulary. So that's a new word now that Logo knows. But if you don't use the word some way, so for example, right here we use the word, right? Then nothing's going to happen. So let's go back into Code Sculptor and actually use it. Let's say print rectangle area 3, 2. We tested this one already. We know that should be 6, right? And let's do another one just for kicks. Rectangle area 3, 5 should be 15. And let's see. There we go. Oh, good. 6 and 15. So it worked. But you see, both of these functions, the one written in Python and the one written in MicroWorlds, both make use of this this same construct, the same idea that there are two inputs coming in. We have names for the two inputs and a name for the output that only exist inside this function, and then we have an output.